Alright, so let's do a full-on example with differential equation with initial conditions. So let's consider a linear differential equation, second order, so y double prime plus 4y prime plus 4y equal to t. The initial conditions are easy, so let's make them both 0. Okay, so the first step is to take Laplace transforms on both sides. So let's recall from the previous section that the Laplace transform of y prime is s times capital Y minus y at 0. And the Laplace transform of y double prime is s squared times capital case Y minus s times y at 0 minus y prime at 0. Well, the good thing is the initial conditions are both 0, so none of these terms are here. So the Laplace transform of the left-hand side is s squared times uppercase y plus 4s times uppercase y plus 4 times uppercase y. And the right-hand side, the Laplace transform for t is 1 over s squared. Factor out the ys, we get s squared plus 4s plus 4 times ys equal to 1 over s squared, which tells us that y is equal to 1 over s squared times s squared plus 4s plus 4. And we know the second factor is equal to s plus 2 squared. So now we use the method of partial fraction. So we can assume 1 over s squared times s plus 2 squared equals to a over s plus b over s squared plus c over s plus 2 plus d over s plus 2 squared. And the first thing we do is you multiply by the common denominator. So we get 1 equals to a s times s plus 2 squared plus b times s plus 2 squared plus c times s squared times s plus 2 plus d times s squared. So the first, we can use the trick we used before. So if we plug in s equal to 0, then we get 1 equals to 4b, which tells you that b is 1/4. And we can plug in s equal to negative 2, then we get 1 is equal to 4d, which means d is also 1/4. To figure out what a and c are, we need to take the derivative of this. So take the derivative. So we get 0 is equal to product rule here, a times s plus 2 squared plus 2as times s plus 2 plus 2b times s plus 2 plus product rule again, 2cs s plus 2 plus c times s squared plus 2d times s. So now we can plug in 0 and 2 again. So if we plug in s equal to 0, you notice that a lot of terms went away. This went away. So we get 0 is equal to 4a plus 4b. And we already know what b is, so we can figure out what a is. So that means a is equal to negative b, which is equal to negative 1/4. And let's do the same thing. We plug in s equal to negative 2, then we get 0 is equal to 4c, this case minus 4d, which means c and d are the same number, which is 1/4. So that means ys is equal to negative 1/4 times 1 over s plus 1/4 times 1 over s squared plus 1/4 times 1 over s plus 2 plus 1/4 times 1 over s plus 2 whole thing squared. And to figure out what the original function is, little y of t, all we need to do is take the inverse Laplace transform. So the coefficients stay there. the first two terms, there's no shifting. A is equal to 0. N is equal to 0 for the first one. N is equal to 1 for the second one. For the third and fourth terms, there's shifting going on. A is negative 2. And N is 0 and 1 respectively. All right. So this is just 1, or technically t to the 0. And this is t. And this is e to the negative 2, t times 1. And this is e to the negative 2t times t. So the solution for this differential equations with initial conditions is y equal to negative 1/4 plus 1/4 t plus 1/4 e to the negative 2t plus 1/4 e to the negative 2t times t. All right.